Yeah. Okay.
Alrighty. Um, yeah, so great to be here to have my esteemed panelists to join me to discuss security. So I will have you to introduce yourself and what you do when I ask the questions, and you can tell all the people who are probably not familiar with what you do who you are just yet. So we're going to talk about security, and security is a large topic. We could be sitting here all day today and tomorrow, and we won't finish. So I wanted to zoom in. I want to zoom in a bit. I want to zoom into the Web3, digital assets. So considering all the challenges and opportunities we have, if you were to give everyone here top one, top three, or top five, your choice of the essential controls or pillars in a security framework, what would it be? I'll start with Robert, who sits next to me. Yeah, introduce yourself and what you do, please.
Hey, I'm Robert. I founded OtterSec. We do security auditing. We work with both on-chain protocols, as well as L1s, exchanges, anything in between. We look at a lot of code, we read a lot of code, and we try to find security issues and report them ethically.
Hi, I'm Alex Rawitz. I'm one of the co-founders of Dimo. We're building a connected vehicle platform that's built on Web3 components. What we're trying to do is really take the automotive industry, $1 trillion industry around the world, and upgrade the digital infrastructure upon which it runs to make data more available to people, users, drivers, and really all kinds of automotive services.
Hi everyone, I'm Ranvir. I'm the co-founder of WitnessChain. At WitnessChain, we are building a layer to unify DePIN economies. We build consensus protocols on physical state, such as proof of location, bandwidth, and so on eigenlayer. And this helps you build new economic instruments on DePIN.
Cool. So, Ranvir, stay on the mic. Tell us your top one, top three, or top five core controls in terms of security for the Web3 industry.
I think, in my opinion, the most important is crypto economic security. This is a new era of security where even if some security property gets violated, you can attribute some economic value to it and get the funds out to the victims. So it's a security which I think changes the paradigm a lot. Even if something is vulnerable, it fixes, it has a remedy for it. Well, of course, these is built on the foundation of operational security and security within the code itself. So those are my top three.
Cool. Alex?
Yeah, one thing that we think a lot about at Dimo is hardware security as well and infrastructure security. We're connecting cars to our platform, and that's actually something that has already been exposed as a major security vulnerability throughout the auto industry. Almost every automaker has had to endure hacks, has had to see their code get really exploited in some way with over-the-air updates. So for us, we think a lot about hardware security, and one of the principles that we ascribe to there is just the need for open sourcing as much of the hardware and as much of the firmware as possible. So that's something that we've approached in our ecosystem. Hardware manufacturers are required to open source their schematics. The firmware is open source. And what that does is that helps actually the community become a lot broader, the security community really become a lot broader in terms of who is actually assessing the vulnerabilities that exist at the hardware level. At the end of the day, a lot of the digital products that we consume and a lot of the experiences we have are rooted in some physical product itself, some chipset. And it's really important to think about the security in the physical world as well.
Cool. Robert?
Yeah, when we think about security, we think it's really important to have security at every stage of the process, right? If you think about how bugs actually get to production, you have the developer who's writing the code, then maybe you have some internal testing, then maybe you have an external review, then you have a bug bounty program, and then at the very end of the pipeline, you have the hacker who exploited your protocol and stole your money. And ideally, you never get there. Ideally, you catch the bugs earlier in the pipeline. But I think it's really important to stop as many bugs as early as possible, right? And that means writing good unit tests, writing good integration tests. When you're a developer, you should make sure that your developers also understand something about security and that they can write code that has less bugs, because the less bugs that you start out with, the less bugs that you need to actually catch via auditing or internal testing, stuff like that. And I think overall, by pushing the bugs left, you make it a lot easier to write safe code.
Cool. I think I'm hearing a few keywords and a theme over here. We're talking about the trust. We're talking about open source, the transparency, so the entire community and industry can actually collectively make those protocols better. And also I heard about the shifting left, essentially catching on the vulnerability sparks early before they actually eventuate. And those are actually themes maybe for the Web 2 and Web 1 world, still actually apply to Web 3 world as well. Yeah, so thank you for your insights. The next question I'm going to go to Robert. So I looked up your website and I read some of the reports. All the reports are fantastic things. And one of the things on your website really caught my eye was the vulnerabilities you found were actually worth over $1 billion, right? That's quite impressive. So wondering, out of those vulnerabilities you found, tell us one or a couple that's most impressive or most interesting, and how you and your team address those bugs or vulnerabilities, please.
Yeah, I guess the highest dollar amount vulnerabilities are probably going to be L1s, right? That's where all the value accrues. And if you have some sort of logic bug or consensus issue there, you can steal all the money from the L1. And I don't think I should name the L1s, but I think there's definitely been some really cool bugs that we found. And I think you find those by looking deeper in the stack, right? I think you have auditors who, for example, look mainly at smart contracts, and they look at how Solidity code interacts. But if you want to find really cool bugs, you should look at how the VM works, right? Like maybe the Geth implementation, or in the case of all L1s, a lot of it's open source. Look at how the VM works and see if you can find something that breaks one of the invariants. And I think definitely the coolest bugs that we found have been, I'd say, lower in the stack, right? Like very unique bugs that I don't think would be replicated anywhere else. If you look at the GitHub commit history, you can probably, I think they sometimes tag us, so you can probably find us in there if you really want to look for it. But yeah, I think overall the coolest bugs are the ones that I think are lower and in places where other people haven't really looked as much.
Cool. So how do you, let's say those bugs, the coolest ones you found, like buried in one of the GitHub open source project commits, and how do you then go from there? How do you help the developer or industry to patch those bugs?
I think the nice thing about most bugs, I would say, is that once you find it, it's relatively easy to patch. Right? I think the hard part is finding the bug. And actually, we have this really common saying internally, is that all bugs are obvious in hindsight. Right? If you know what the bug is and you know what to look for, it's super easy to find it. Right? It's like you're missing some sort of access control here. You should have rounded in the correct direction. You should have checked this thing, but you didn't. But I think the issue is there's just so much code and so much surface that it's hard to actually look at the right thing at the right time. And I think that's really where auditors come in, where we're able to process all this code, think carefully about the invariants, and find the critical bugs when it matters. So I guess getting back to your question, when you actually find the bug, I think it's relatively straightforward. We just write the patch for it. We tell them, obviously we do it securely. We let them know. We message them directly, and then they issue a patch. And actually, the patch process for some of these L1s is also interesting, right? You see a lot of these L1s have public reference implementations or repositories of code. But what some people might not know is that they also have a private version where they land security patches before it becomes public. So when we report a bug, for example, against one of these L1s, what they'll do is they'll write a patch. They'll push it against their private repo. They'll invite us. They'll send it to all their validators, and then only once everyone has patched will they make it public. So what you see on these repos is actually delayed by probably a few days to a week.
Honestly, I think it really drives home to what you talked about just now, the shifting left. If people who develop new versions, new protocols that will actually have security in mind, it will eliminate a number of bugs appearing. So thank you, Robert. Now, Alex, Dimo, again, I looked you up. You guys are doing something really interesting on the utilizing vehicle data. Questions on your thoughts on the underlying security protocols and mechanism that you put in your product to specifically addressing the unauthorized access and maybe data manipulation as well. Especially, I know you guys moving towards tokenomics and NFTs, etc.
Well, one thing that's really interesting is that the auto industry is already grappling with a lot of unauthorized access issues. One of the things that occurs, it's a new trend. So in the last 3, 4 years, 5 years, automakers have started to, with their car, produce an app. So you buy a new Toyota, you get a Toyota app. That's pretty nice for most people. But one of the things that they didn't think about, which is kind of amazing in hindsight, but like really didn't come up at all, is a car is typically sold 3 or 4 times over the life cycle of its over its lifespan. 20 years, most cars are on the road. So a car is sold 3, 4, 5 times, and there's no way to actually transfer. It's extremely complicated. If you've ever gone through this process, you have to get on the phone with Toyota and like go through layers and layers of customer service. There's no way to transfer ownership of the data. So the internet is filled with stories of people who've sold their car. They actually are able to hang on to access to the vehicle connection, and now they see where some other person, the next owner, is driving all the time. People tell stories about how I sold my Tesla, and now I can see the Spotify playlist that the next person is using in my Tesla. So right from the get-go, the auto industry has not been built with kind of that mindset. And a couple of things that fix that are, one, like better user ownership of the data itself, which is where, the approach that we've taken, where users are actually custodying the data themselves. They're in control of who they are and aren't sharing their own data with, as opposed to it just living with the OEM servers. And 2, transparency and auditability. So in the case of what we're building, we can make sure, you as a user, when you connect a Dimo device or connect a car to Dimo, you can see all of the people that actually have access to your vehicle data. And there's a very easy activity log with which to see that. And that also exists in APIs and at the protocol layer itself. Really, the entire auto industry is going to have to shift in this way, where they're more in control and providing users more control over their data access. The other wrinkle in all of this is, of course, that vehicles are starting to get over-the-air updates. So now people's cars will update overnight. And most users are really unfamiliar with this process, and they've been surprised sometimes to wake up and find that their car works differently, or a feature they had enabled is no longer enabled. And having a change log, so to speak, is actually really important for users. We saw another incident where Nissan's APIs went down for like 3 days, and users are like, great, now my app doesn't work. I can't lock and unlock my car from the app anymore. That's not fun. So I think that all of a sudden we're going from treating cars as a purely mechanical item to having to think about like what is the digital nature of these vehicles, how reliable are the APIs that the automakers are building on, what kinds of services are we expecting. Tesla wants to launch a robotaxi. Well, how robust are those APIs going to be, and who's going to control the access there? So we've been thinking about that from the very beginning, and want to create this credibly neutral data layer that actually can track those sorts of access points and those vulnerabilities.
Cool. So I think many years ago, probably 4 or 5 years ago, we were all watching those blockbuster movies, right, where people hack all the cars and they're going to go all over the place. And I still have the memory of when I was early in my career, I was working for a car manufacturer, and we spent month and month developing the head unit, because we know once it rolled out, it's going to be 20 years, it won't be able to patch it. Now, the world changes, right? Connected.
Yeah. I'm sorry, what?
So the world changes.
Yeah.
All the cars are connected these days, almost.
Yeah, and look at Tesla, they every 3, 4, 5 months, his story hits the news. Oh, there's a Tesla recall on 1 million cars. Well, they don't have to do anything with the cars other than update them over the air. But that is the model that has been changing in the auto industry, where it used to be once the car rolled off the manufacturing line, that was the last time the automaker was going to see it, and it had to be set as it rolled off. But yeah, the world is changing, and we think that an important part of that is for users to have control over that software. Like, imagine Tesla can crack full self-driving. Well, what if, as a user, I could actually just download the Tesla software to my Toyota? You can end up with a much more modular framework in the automotive industry, and that's been happening in the hardware, on the hardware side of vehicles for a long time, where we're going towards the skateboard, as they say, and you can start to layer that in at the hardware layer as well. In fact, you could even say it's kind of a return to the days when you used to like put your own stereo system in the car. You're really kind of bringing back modularity into the vehicle, and you might find one day that, okay, well, I like the Tesla self-driving, but I think that the safety features of BMW software are better, so I'm going to have those. Like, what if there's a world where you could actually, compose your own car based on the software that you can download to it, and you just have a skateboard, so to speak?
I'm really looking forward to that future. I'm such a car fan. Now, Ranvir, proof of location, proof of bandwidth, these are the things from your products. So maybe you could take us to how your new proof mechanisms are different to the ones we're all familiar with. And also probably pivoting to the security lens as well, how those new proof mechanisms can help security and functionality of like Ethereum, for example.
Definitely. So what we are building is broadly classified as consensus on physical state. What this means is there is a global set of validators, and in our case those are eigenlayer operators, which are validating physical attributes of assets that constitute depends. Now, I would like to draw an analogy before Bitcoin, right? Before Bitcoin existed, tokens existed. There were airline points, there were credit card rewards, and so on. What Bitcoin changed is, or Ethereum changed is, there is now this token created, which is validated by a global set of nodes. And now on top of that, people can develop dApps or anything without trusting any single entity. So it enabled this whole new alternative economy, $3 trillion, I didn't check the current value, around this, because people can trust that whatever, if I have 1 ETH, I actually have it, and I can't double spend it. Now, extend that, these are digital assets, extend that to physical assets. If you can prove these attributes for physical assets, you can use them downstream for other applications. You can build, for example, deepin DeFi on top. You can compose multiple deepins together, because now asset on one deepin can trust asset on another deepin. You can build a distribution channel, and so on. So that's the motivation behind this proofs of physical state. If you want to draw a difference between what current consensus mechanisms are, they are proofs for, let's say, execution. Right? These are proofs of physical attributes such as location. Now, to go into details of how these work, let me give an example of how proof of location works. It's the way it works is you can think of these validators as quote-unquote GPS satellites. Right? You need to perform triangulation on some on a node to determine its location. Now, rather than performing it over there or through any medium, you can perform it directly through the internet. Now, there are a few challenges here. The internet is not, internet infrastructure does not run in a straight line, so you have to learn the manifold of, you have to learn the internet topography throughout the world. So we developed that manifold. The second thing is you have to make it Byzantine fault tolerant, so that you can have anyone act as those quoted GPS satellites. Right, so we have this thing called BFT, Byzantine Fortified Trigonometry. It's a play on BFT that enables this proofs. But what's important is, like, once you have these physical attributes validated, they can be used downstream to, let's say, tokenize physical assets themselves.
Cool. So just to, thank you for explanation. If we dive deeper into security aspect of these new proof mechanism, what would you say is better, or how is it improved compared to traditional ones, or old ones?
Definitely. So, well, a globally validated proof of location, for example, does not exist. So any proof of location that exists right now, like either you have to trust a GPS chipset, which can be spoofed, or you have to do some triangulation on a wireless medium. If you do that, you can get higher accuracies, but you have the vulnerability that if, let's say, a majority of your neighbors are colluding, your security breaks. So it's very possible that a majority of nodes in one city are adversarial. Or you can just create those nodes in one small city. Imagine what happened with Helium, for example, where you have a node in a closet pretending to be somewhere else, right? So if you rely, this kind of vulnerability does not exist if you rely on a global set of validators. Because on a global set, you can make an assumption that a majority of them are going to be honest, or in our case, we are now moving to crypto economic security, so you can make assumption that when a statement is made, it's backed by X billion dollars of crypto economic security.
Cool, thank you. So I think, conscious of time, I wanted to have a wrap-up question for all my panelists over here. So how do you see the industries, i.e. company I work for and yourself, and the community like developers and end users work together to enhance the security in the Web3 for the next frontier? And particularly, you can talk about how your projects will contribute to that collaboration. So let me start with Robert, please.
Yeah, so I think most directly we read code and we report bugs. So I think we hopefully directly contribute to the security of the products that we work with. But I think maybe more indirectly, I think one thing that we also try to do a lot is we have a lot of blog posts on the sorts of interesting bugs that we find, interesting information about a particular VM, or just things that we've reported in the past and write-up of a particular bug, for example. And I think in general, by contributing to the knowledge base or the shared public knowledge base, we're able to make it so that other people are able to find similar issues. And I think that we see this a lot actually on Ethereum, where there's a very robust knowledge base of past vulnerabilities. People have a strong culture of sharing their findings on Twitter, for example. And I think it makes it so that a lot of these issues that were once very complex and hard to find have now become a lot more shallow. And I think that's really important and something that we and everyone else in the ecosystem should strive for to raise the overall water level of security.
Global citizen. Alex, what are your thoughts?
One of the things that keeps me up at night is just the experience that the average user has in crypto. Almost every day, I feel like somebody in the Dimo community shows up to say they clicked a malicious link and now all their tokens are gone, and is there anything we can do to help? And there's nothing we can do, and it's just unfortunately a sad reality of the way that the tools are in this space, and obviously the noise and the scams and all of that other stuff. But I think that to expect users to be fully kind of self-custodial and to be able to navigate all of the complexity in the space and just in the world generally and just not ever make a mistake is probably too high of a bar. So one of the things that I'm most excited about is we're finally seeing another wave of wallet infrastructure come out in the crypto space. New tools like Turnkey and Privy and others that can strike a balance between hiding some of the wires, extrapolating some of the complexity from users, but not giving up fully the to centralized control what users can and can do with their tokens. They can still export a seed phrase and still gain control really easily. And I think that for most people, finding some balance between a self-custody mechanism and a centralized entity that's helping them to achieve their goals and operate as a user is going to be what leads to better security, at least for just the user experience level here. I think, from Dimo's perspective, we're going to do what we can to contribute to kind of a better better mechanisms in the auto space. Hopefully, we can be on the leading edge of some of these new wallet technologies and bringing that to the forefront and bringing that into user experiences. But overall, it really does come down to like all of the players in the space acknowledging that there's a long way to go and that there's really no destination at the end. It's kind of all a constant effort of improving in an ever-changing world.
Cool. Definitely, I think there's massive uptick in the MPC wallets in the industry, and now actually can mitigate the risks of what you talked about. Now, Ranvir, what are your thoughts?
So what we are looking forward for is composability, in security sense, is composability of proofs. So what I mean is depends are a way to observe the world. Now, if you want to observe attributes of a physical asset, there are various, like for example, Dimo here is observing some attributes through the data that it receives. Can you compose multiple proof systems together to corroborate into like one single statement that A, this thing exists, or B, this thing doesn't exist? So composability of proofs is what we are looking for. In some angle, EigenLayer is kind of doing that on an economic angle where multiple AVSs have their own systems, but they share the same economics. And we would like to expand that into the physical realm.
Cool, fantastic. So I think that's all the time we have here today, and really appreciate your time and interesting thoughts on my panelists. And that's all from us. Thank you.
Thank you.
Cheers.
Thank you for having us.